Hello, good morning, good afternoon, and thank you very much, everybody, for joining this episode of eCHO. This is episode 145, and it's going to be all around the somewhat confusing Gateway API or API Gateway. Which is which? What does it mean? So to help us kind of get our heads around all of this, I'd like to introduce Marino. Let's introduce yourself. For the few people that don't know who you are.
Hey, good morning, good afternoon, good evening, everyone. My name is Marino Uche. It's nice to be here. It's actually very, very nice to be here because I attended like I think the very first episode of eCHO, like way back in 2021. And it was like a complete trip for me because I was learning that this CNI, this container network interface, was doing a lot of SDN things that I was already doing with like NSX, VMware NSX. And then you start to see the magic of eBPF and what it can do. And it just got me hooked a little bit. I kind of fell off, and then I started to see how much the Cilium ecosystem and community was growing. And I just needed to be a part of that. But I didn't realize that I'd end up being on an episode at some point in time. So Dan, thank you so much for having me here.
Thank you very much for taking the time to come and join us and help us get to the bottom of this slightly confusing state that we now find ourselves in with Kubernetes. We have API gateways and we have gateway APIs. So before we kind of delve into that a little bit, as always, just kind of a bit of a lay of the land. There's no major headlines. I think we're in that bit of that quiet summer period at the moment, so we don't really have anything huge to bring you from that perspective. So largely at the moment, the main things to make people aware of really: eBPF Summit, 11th of September, all virtual. We've got some already great keynote speakers kind of lined up. We also, the CFP is still open for a few more days. I think 5 more days. So if you have projects, personal projects or professional projects, just a good various ideas that you want to talk about all around kind of eBPF, maybe use cases, how you're using it, then please get a CFP submitted whilst you still can for eBPF Summit. And likewise, at KubeCon, we've normally had CiliumCon. However, for reasons unknown, it's now CiliumCon and eBPF Day, so kind of split out into two. So if you have projects, ideas, anything that you want to talk about, either about Cilium, Cilium projects, or about eBPF, then you have a few days left. You have 2 whole days left to get your CFP submitted for CiliumCon, eBPF Day, or any of the other co-located events days and things like that as well. So time is drawing to a close on those 2. So that's kind of the main bit of news that we have at the moment. I think we'll probably just kind of delve right into it. So confusing. I've been kind of doing various bits around kind of Gateway API, which is an upstream project. But people refer to it as API Gateway and they get confused and stuff like that, whereas API Gateways are also a thing as well. So I'm gonna hand this over to Marino, put him straight in the hot seat. Like, what's going on?
I'm glad you brought this up because API gateways are, to me as a network engineer, a router, right? It's doing something, it's routing something, it's taking on a request and forwarding that request out to the necessary, receiver or responder. And that's just standard networking. And when you begin to realize what you're doing, sure, if you've ever played with like layer 3 routers, the concepts and fundamentally it's about the same. But what an API gateway is there to do is actually to be a reverse proxy for a lot of connections, inbound connections towards services. And why you might want to do this is, look, you're never going to want to expose your APIs directly to consumers or clients or end users. And this is for a variety of reasons, like security, right? You don't want anyone being able to just get in there and capture information freely. Maybe there are APIs that are open that don't require that authentication. But if you've got, let's say, PII, personally identifiable information that you're handling, and that touches a lot of systems, That's the situation where you don't want to expose your APIs very cleanly. The other situation too is like APIs are accessed by a variety of endpoints or consumers. And if you think about it, APIs have this buffer window, this window to be able to accept communications and respond within a given amount of time. But if you overload that endpoint, that API, then it can fall over, right? Especially if it doesn't have something that can tell it to scale appropriately. And so this is where API gateways come in. They're kind of a mediator of sorts to be able to receive those connections, and based off of varying factors or conditions, we can make routing decisions. We can make the decision to not even forward the traffic because you're lacking some form of authentication. Or you might be in the situation where you're trying to rate limit. Here's a good example. Maybe you're using ChatGPT free version, right? But you're limited to how many queries and prompts you can do per hour or per day. But if you paid for the plan, right? If you've paid for the monthly subscription, you have a larger bucket. I think it's almost unlimited. Now, if you think about it, I don't know how architecturally it works or how OpenAI is doing it, but I would assume that they're using some API gateway of sorts that front ends a lot of their services. But also, what that API is doing is it's determining if you're a free user or a paid user, and it's basically routing you appropriately, allowing you to do certain things, and then saying, "Hey, your limit's up if you're a free user." So the gateway is actually doing that. So it's helping in a lot of ways. But then you have this concept of gateway API that has just come out of like left field. It's been around for probably 2 years now, and it's something that's
Yeah,
very.
it's
Go ahead.
pretty new, but it went version 1 at the last KubeCon in Paris.
That's right.
Yeah, that's right.
Yeah, and when you think about Gateway API, it's a very Kubernetes centric model. It's meant for Kubernetes. It's meant for a way to break out how we define infrastructure and how we define the consumption of that infrastructure. And why that's important is we want to create a decoupling, but we also want flexibility in the way we consume like ingress capabilities. Now, this steps into a whole different realm a little bit, because when you think about ingress, the whole concept of it is to bring connectivity into your services that exist in some environment. Uh, if you operated data center environments a long time ago, you would probably use a load balancer for some of that ingress, where you've got a firewall behind it that processes a request. Maybe it's an all-in-one device or what they call unified threat management device. But that's an ingress, right? It's receiving a request or connection, and it has to evaluate it. Now, with Gateway API, before that even existed, we had this concept of ingress in Kubernetes, which is exactly what I just described it to be able to do. But it was a very restrictive model, because if you wanted to swap controllers or use a different ingress controller altogether, you actually had to deploy that ingress controller and repoint all your resources to it. That changes in the Gateway API spec, because you could define all of your infrastructure ahead of time. And then when you're defining your routing, you can go ahead and define which gateway you want to choose and swap it out after the fact. So fundamentally, you'll think, hey, you've got API gateway on this side and gateway API. Don't they kind of do the same thing? Yes and no, right? The API gateway you can think of it as a function, as a device that's doing something, whereas a gateway API is a set of standards as to how we go about achieving ingress with the different available options that are out there. But in a lot of ways, like when you think about what's going on with these resources, what's behind the scenes, they're ultimately doing the same thing.
I suppose, kind of a question then, really. Gateway API is, you're going to be accessing your HTTP routes directly. From an API gateway perspective, is that less likely to be accessing that directly? Is that going to be sat sort of in the middle of your stack to a certain degree, and then front end and then ingress or something like that? Is the model, is that kind of slightly different, would you think?
That model can vary in a lot of ways. If any of you watching are very familiar with service mesh, it kind of offers up that same approach of what an API gateway would offer, right? And you think about a service. The service has to not be exposed. The service has to be front-ended by something. An API gateway tends to do that outside of Kubernetes for a variety of different things. The placement, however, is going to depend on. Okay, and it depends kind of response.
Yeah, very political answers here. Yes and
varying
no.
conditions, varying circumstances, your workload and your applications are highly going to dictate what you decide or what you end up picking anyways. But the reality is, like, is everyone running entirely on Kubernetes? Is everyone running like workloads elsewhere? Like it's a mix that we tend to see. And sometimes it's heavy on the Kubernetes side. Sometimes it's heavy on the, the bare metal virtual machine side or native services. And you just need something to be able to adapt to these varying kinds of workloads.
Yeah.
But yeah, it depends. And the placement is going to depend on those varying factors.
So, I mean, it is very easy to get kind of caught up, especially if you spend all of your time in cloud native land, just thinking everything is on Kubernetes. Everything everywhere is on Kubernetes. But like API gateways are not new, are they? They predate Kubernetes. They've been used. As you say, some of them may have even been physical appliances and things like that.
Yeah, my first bout with API gateways was, I think Cisco had something, I can't remember the name. It was like an application engine or something like of sorts, which basically did what an API gateway was doing, right? It was a hardware system that received a lot of requests from various levels of the OSI stack and would just process them accordingly. And then there are other flavors that you see out there, like you could turn a lot of open source proxies into an API gateway. We've seen it happen with Envoy. We see it happen with Nginx, even HA proxy. They exist out there, right, in various forms. I think it just comes down to the fact of what you're looking at, what your workload style is. But a lot of this predates Kubernetes. Like we were doing a lot of this API gateway stuff before Kubernetes actually started to shine a lot more. Kubernetes in itself is a bunch of APIs, right? Like, and you would think that, hey, this is the perfect place to start using gateways, but it's such an intrinsic system that you can't just simply stick API gateways in front of every single control plane component in Kubernetes. Yep. That could also create a lot of other problems too. But when you think about it, when you think about the usage of the API gateway, it served some varying purposes for the way we transact with websites, the way we transact with services on our phone. And a lot of this doesn't even depend on Kubernetes or even use Kubernetes behind the scenes too.
So there you go. Yeah. Well, okay, fantastic. So that's a bit of an overview in terms of the differences between Gateway API as a standard that various vendors have written or update their components to adhere to a certain degree, almost the history of API gateways and where you would find them. So before we're going to kick things off, we've got a Leon here saying Dan Marino in the house. Thank you very much, Leon. And a quick question from Carlos here. It would be great to cover Gateway API with Cilium in the context of EKS. So yeah, I'm going to defer that to my great colleague Christine, who is effectively our Gateway API champion, and we'll see if we can get some content put together around all of that.
That sounds like a Carlos and Christine episode there.
Absolutely. So what we're going to do now is, and I don't know why I volunteered myself to do this, it's Friday, but we're going to do demos anyway. We're going to stand up pretty much everything. So from an architecture perspective, as always, we're going to use Kind, get a quick 3-node cluster up and running. We will deploy Cilium on top of all of that with a couple of things enabled. So we will have layer 2 advertisements enabled so that we can do load balancer services. Then we will deploy Kong Gateway on top of all of that. And then we will configure Kong Gateway. Well, I will attempt to, whilst being driven by Marino, configure Kong Gateway, and we'll create some services and some routes and kind of talk that through. So let's begin the demo, as it were. So I will bring my terminal in. And if anybody can't see that clearly? Make yourselves known in the comments. We good?
It looks clear to me. Yeah. I'm curious, how long did it take you to put together this environment and this demo?
So, I mean, it's actually been a learning exercise from my perspective. I've not really done a lot with API gateways. This has been kind of a learning exercise for me. So I think largely maybe a good afternoon, maybe a day or so. And everything that I'm going to be demoing as well is also going to be added up to the iSurveillance/eCHO repository. So after this, I'll get that merged. But there'll be an episode 145 folder, and everything we're doing is so this is actually down to Marino's episode that I did with him on Monday. Everything's all being driven by make files just to generally make things a bit easier, but we'll kind of break it apart so you can kind of see what we're doing. So let's just quickly step into here. So we've got a couple of files in here. The main thing is the make file, which effectively is going to take care of automating a bunch of things. So you can see the make file, then you can see kind.yaml. The kind.yaml has, well, I'll show you what's in there. So that is effectively the configuration that we have. So as I mentioned, 3 nodes, control plane, 2 workers. Important here from a networking perspective, we have disabled the CNI, so there'll be no networking out of the box. And we've also disabled kube proxy as well. 2 reasons for that. One, the CNI is going to be Cilium, so we don't need the default kind CNI. Secondary, we are going to be using kube proxy replacement, so we don't need kube proxy running there at the same time. So what's happening now is we've kicked off our echo session. We've kicked off our echo session. We did that 15 minutes ago. We kicked off our deployment. We are standing up our cluster, so 3 nodes, and then we'll add Cilium to it afterwards as well. So another quick question here. This is insightful. Well, that's good to hear. So very good question. So all previous episodes are available on YouTube. So if you find the Cilium eBPF YouTube, I don't even know what that's termed as, not repository, account, whatever, you'll find the eCHO videos all there. And as I mentioned, there's a GitHub repository filled with any bits of code that we use and things like that. So we now have our cluster up and running. And I can't type. So there we go. We can see core DNS isn't working because we've got no CNI. So let's add a CNI. So if I scroll back up a little bit, we can see here we're installing the current, let me pop this back off. The current version of Cilium, 1.16 is coming out very shortly. Main things to really be aware of here are kube proxy replacement and layer 2 announcements as well. So that means we'll be able to do load balance services locally and things like that. And then finally at the bottom here, we have we've run the command Cilium status --wait, and what that will do is instead of printing out the status at the moment, it will effectively wait for everything to become green. So as you can see, Cilium status, everything is okay. The operator is okay. Our daemon sets are up and running. Yeah, pretty much everything is all up and running. We can see the versions of everything that's actually there. So the next thing that we're going to do is to enable the layer 2 perspective of this. So I'll quickly show you what that looks like. There we go. So these are CRDs that are added as part of Cilium install. One is the load balancer IP pool. So this is effectively a range of a slice of networking that is going to be our pool of addresses that we will make use of. These addresses effectively sit within the range that a kind cluster would make use of. And then beneath that is the announcement policy, and that is effectively how Cilium is going to announce these layer 2 changes within the cluster. So when we create a load balancer service, its IP will be taken from that IP pool, And then how it's announced to the outside world is done through the announcement policy. And here in the announcement policy, we can basically see which interface it's going to use in order to announce those. And also, is it going to do external IP addresses? Yes. And it will do load balancer IPs as well. So that's exactly what it's going to be announcing. So we've applied those. So we now have an IP pool, and we now have a methodology for announcing our layer 2 addresses. The final step from my involvement in all of this is to install Kong. So if I do a make Kong, pretty simple in terms of what it's doing. We'll step through this in a second. We'll just let it finish doing what it's doing. Right. So what have we done here? I don't know if you want to walk through this, Marino.
Yeah, we could quickly walk through it, right? So we could basically go ahead and install Kong with the Helm chart. There's a lot of different ways you can get it up and running as well. But Helm is the easiest, especially if you're using Kubernetes. But there's a few things to consider. Like, we actually have to assign it an enterprise license. And if you notice that the actual license that we use is an empty license, this is just indicative of the fact that this is open source. And that's okay, right? Like, if you ever decide, hey, I want to go a little bit more enterprisey, then you can come in and update the license, and that just unlocks a bunch of other features. And then we go ahead and we just have to create a key or a secret, a TLS secret for the cluster itself, for Kong to be able to have some just intrinsic security within the management and control plane itself. But once it's deployed, what's interesting is there's a few ways you can actually deploy Kong Gateway. What's also interesting is the way Dan deployed it is standing up specifically Kong Gateway itself inside of Kubernetes. There's another flavor called Kong Ingress Controller that could also be deployed as well, which is a little bit more Kubernetes centric, and you're actually configuring it declaratively using Kubernetes primitives. So you'll see a bunch of CRDs that show up that you could basically program. But for the most part, you treat it as either an ingress controller or a gateway API endpoint. So we're at the point now that we have the gateway up and running, and we effectively can go ahead and just validate some things. So since you have it up, why don't we take a look at what's been deployed?
Absolutely. So at this point, it's whilst we've been talking, images will have been pulled. Startup script should have effectively finished. Let me might have to make this window a little bit bigger. There we go. So no, there we go. That's everything that's kind of important to what we're talking about here.
Exactly. So what you see highlighted is a few things, right? Let's talk about the Kong init migrations first. The Kong init migrations is kind of a bootstrapper to basically get configurations and the Kong environment up and running. So at a base, like that pod should eventually disappear. It shouldn't be in the system after a while, unless we invoke it again. And then there's two other pods, the Kong CP Postgres SQL, as well as the Kong CP Kong, which that's actually our control plane / data plane. But the Kong CP Postgres SQL pod, it's there because we have to store configurations somewhere. There are a few modes in which you can operate the Kong gateway. You can operate it with a database, which is known as traditional mode, or you could operate in DB-less mode. In DB-less mode, where we don't deploy the Postgres SQL server or another flavor, another SQL environment or database environment, we're running configurations in memory, which actually limits us in different ways. Like we can't write to the admin API. We have to reload our configurations consistently, but it's meant to be a lighter weight operation. There are other challenges too, but it also helps with like optimization of the way you do your routing and whatnot. There's another option where you could just deploy a data plane, and it'll be a Kong gateway, and the control plane lives in the cloud. We're not going to discuss that deeply today, but if you're like really interested in that cloud aspect of it, reach out. We could have a conversation about it. But what's going on here is we've got another pod, the Kong CP Kong. That's the gateway itself, and you'll notice that there are 2 out of 2 pods. Do you want to output the contents of that pod? So we can see the containers in there. Yeah, let's describe it and see what containers are in there.
Right, so we have, is this a container? Oh, that's the init container. Sorry, bear with me.
There's the second container I see there. There should be one more.
Ingress controller. Yep.
Yeah, there we go. So this is actually not the specific. I don't think you deployed the Kong ingress controller specifically, right? I think you deployed
not specifically. No, I just deployed the gateway.
Exactly.
This is embedded within it.
Exactly. So what we've actually got going on here is a split. We've got the control plane aspect as well as the data plane aspect. We do this because, let's say you wanted to upgrade the control plane without affecting activity on the data plane. You still want traffic to be forwarded, but configurational changes can't be made because the control plane is down. You don't have an entry point to be able to make those changes. So that's why we kind of separate it out, but it also provides some other scalability capabilities. Now, that entity, that pod, is going to do all our routing for us. We're also going to be able to talk to that pod and specifically the container that allows us to provide the configuration. And then simultaneously, the proxy that lives there is going to do all the routing for us towards our services wherever they exist. Now, there's a couple of ways that you can establish your routes and your services. And I think we should also define these terms as well, because in a lot of ways, they resemble things in Kubernetes. So let's talk about some Kong primitives for a second. So we've got a gateway, right? And it's an entity that processes requests. Now, it's processing requests for something called services. Services is the first concept in Kong Gateway, where these are just endpoints. These are API endpoints that serve up something, data, maybe to process some additional data, maybe to do something, whatever. But it's a service. You can think of it like a service in Kubernetes, an endpoint in Kubernetes. Then we have this concept of routes, which tell us how to get to these services, like where they exist, and then simultaneously what to do when that traffic has to arrive at that destination. This might start to sound a little bit familiar if you've ever worked with service meshes. And the reason why we have the setup for routes is because maybe we're trying to do a canary deployment or a canary launch or a blue greens, or maybe remember that example I talked about with respect to OpenAI and using a free tier versus a paid tier? Maybe that's where we're influencing that routing. Maybe we're doing some rate limiting. And so we have to think about ways we handle the inbound requests because we don't want to overload the service as well. There's this other concept called consumers, which, if you think about it, a consumer consumes a service. So a consumer is you can think of it as a client. A client can be anything, though. It could be Dan, it could be me, it could be Christine, it could be another service, right? It's where we define all of this information. And then we have something called upstreams. So upstreams actually is the endpoint itself. It's the actual service endpoint itself. Because the service, if you think about it, is meant to be an abstraction. The service concept, if you think about Kubernetes, the service concept in Kubernetes is an abstraction. If we changed what was behind the hood, behind that service, everyone's still going to communicate to the service address. It's still going to be the same service address. Behind the scenes, something might have changed. We might have rolled out a new feature or something like that. But behind those services are these upstreams. So if you're thinking of a microservice, or if you're thinking of like an API endpoint, that is the actual upstream that developers will configure or program and then serve up to a platform team for them to front end with an API gateway. Okay, so we've got these base concepts. We've got a service that is an abstraction. We have a route, how to get to that service. We have consumers who consume the service. And then we have upstreams, which are our API endpoints. Now we have something called plugins, because we also want some modularity here. There's different plugins, like the OIDC plugin, because we want to authenticate users. There's the rate limiting plugin. There's the rate limiting advanced plugin. There's the transformations plugin. What are transformations? I am receiving do you want to answer that actually?
I'm going to, this is your area of expertise.
Okay.
If you want to talk about eBPF primitives, I'm all ears. But
so transformations, a client is going to send a request, but sometimes the API endpoint can't understand like the schema or the formatting or the language, whatever it is, right? So you need something to transform that. So use an API gateway to transform that request or translate it, right? Another way to say it, into something that the API can understand and then respond to. And then when it responds, maybe it can respond that the client can read, like a consumer can actually read this. Maybe it has to modify the data on the way back, and that's the API gateway. So it could also do response transformation to send that data back in the manner that a client can understand. So that's another type of plugin. And there are a few others that exist as well, especially for AI and whatnot. But
yeah, I mean, we'll see all of those in the UI. I mean, I think the ones like injecting authentication into stuff and things like that, I think that's like such an amazing use case for this sort of stuff.
Exactly. Like the OIDC plugin and the rate limiting plugin are ones that you probably will encounter the most when working with API gateways. You'll encounter different flavors of that with other API gateways. Like Solo's Glue Edge does similar things. Tix API gateway does similar things too. So it's just a matter of looking. But I'm a little biased to come to Kong.
Well, yeah, like this is yeah, like if you don't control the API, maybe, I mean, it's less common these days, but back in the day, you used to get this sort of stuff. You'd buy it from a third party and it would, you know, kind of do what it needed to. You couldn't really go under the covers that much as you could do with the proliferation of open source. So, you know, like adding in rate limiting into the code was kind of out of the question because you didn't have access to the code. You basically had the end product where, you know, the API gateway is there to basically add in these features that you can't implement yourself.
Exactly.
Cool. So that's the ingress controller container. And did we see the other one? Yes.
Yeah, we looked at all the containers. So we looked at the database one, which stores our configs, and then the two pods. Sorry, the one pod with the two containers in it with the control plane and the data plane split out. I mean.
Okay. And then I think this is quite important as well. Really, is the I made that a bit smaller, but it's the only way I can get things to fit, unfortunately. So if anybody has issues, do let me know.
Yeah.
But these are the main areas of interacting with Kong, basically. So
exactly. So that IP that you're seeing, 10.0.1.249, that's the IP for the control plane. So if you pair that with the port number 8001 and pop that into your browser, you now actually have access to the admin interface, assuming you are like in the same network as this environment, right? I think you're hopping into a virtual machine or something, so I think you have to do some port forwarding, but that's okay.
Yeah, I'll show you.
This is where we do all of our configuration. So there's a few, like I was saying, there's a few ways to configure things like services, routes, consumers. You can call the API directly and use like curls with gets or puts or whatnot. But you can also, or you could also use the Kong Gateway Manager, log in there, configure your resources, or there's something else called deck. So you all probably know Kubernetes, and when you do kubectl apply-f in the YAML, you're declaratively deploying something, or maybe imperatively, depending on what's inside that YAML. Deck or declarative Kong configuration is the same thing. You would pair deck with a YAML file, and that configures Kong. So like you would pair kubectl with a YAML to configure Kubernetes, you would pair deck, another CLI tool, with a YAML that would declaratively configure Kong. So that's just another way, especially if you're working with like GitOps or Argo CD, or you're trying to feed this into your CI/CD system for like testing or regression work or something of that nature. That's where the declarative stuff really comes in handy. Now, that's the admin stuff. The data plane, you see that second IP there, 10.0.1.250. That's where all services are transacting. Like literally, I as a consumer or quote unquote end client will transact with that IP address, and behind that IP address is where my services would live. So this is kind of like Ingress in a lot of ways. This is Ingress, actually, just a more hacky way to do it, or non-conventional manner.
Yeah. So we can kind of see here, I've just demoed by curling our load balancer address for the endpoint services, and we couldn't have defined anything at the moment. We can see that there's no services defined at the moment, but we can interact with it in this way. I think one of the things that I found quite interesting before we, sorry, 1 second, quick shout out to Joseph. Hello to you too. Thank you for joining. So we talked about DBless and Postgres and things like that. I wanted to go down the lazy route of using the UI for things like that. And in DBless mode, that isn't available. You effectively have to apply your services in a slightly different way. So there's like 2 or 3 different methods for doing that. You can do that through a secret. You can do that through a config map, or you can do that through some different configuration. We can quickly show you that before we actually go into that. So, oops. If I quickly, here we go. If I can find it. 1 second, see if I can find it. It's in here somewhere. Sorry, there's quite a bit of YAML involved here. It's going to be right down at the bottom, isn't it? Here we are. So if you're using DBless config here, then the configuration that we're going to do through the UI, we can actually put into our values and apply that. So as I mentioned, we can either do that, give a config map, give the name of a config map which contains the key cong.yaml and then the config, or a secret with the same sort of thing, or alternatively, we can actually put it directly in here, and you can see an example of what that actually looks like here. So the version of the config, and then the name of the endpoint, and then the path that if we hit our proxy on, where it will actually send it to. So that's how that actually kind of looks as well. So that's how you do it without the database mode. You basically will have to self-manage this configuration file. Right, so with that, quick recap. Cluster is up, Cilium is up, load balancing is up, Kong gateway is up. Let's actually do some configuring. So what I've done in another window is I have done some port forwarding, which effectively means I can use my local web browser to hit these addresses and these ports here. So I'm basically port forwarding to those. So I'll quickly stop sharing my terminal, and we will go to my web browser. If I can find the web browser, bear with me. Share screen.
Yeah, if you're like me, you probably like five different browsers open with like 50 tabs each minimum.
Yeah, nobody needs to watch me following the Tour de France right now. So let's, right. So the admin portal is 8002. Excellent. So if I make this a little bit bigger, there we go. So as I mentioned, we're port forwarded. So this 199 address is the IP address of the machine that I was actually connected to. And we basically pushed port 8002 from our kind machine to that, so I can access it from the machine that I'm on at the moment. So down here are a lot of the things that you were talking about earlier. So we have our services, we have our routes, the consumers, the plugins, etc., and then a bunch of other kind of important things. Certificates, CA certificates. I presume that's for things like TLS termination and things like that.
Exactly, you're correct, right? Like you could pair this to an external CA if you want. There's a lot of things you could do, but for what we want to probably focus on, I think we'll probably touch just the gateway services and routes, and then be able to connect to some of our services.
All right, excellent. Let's create our first service. 1 second, let me find the docs that I was using, which I've accidentally closed. I think it was this one. Bear with me.
So while Dan's pulling that up, I think it's also important to just establish something about IP connectivity here. The assumption is that your gateway can IP reach the service itself, or what I really mean to say, not the service, but the actual upstream, the actual API endpoint that it's proxying for. So when you deploy, let's say you deployed Kong getting started just for like a little sandboxed environment, it actually will deploy, you could actually deploy it onto Docker. And as long as that container has internet connectivity to say like HTTP bin, and it can route to it, it can proxy for that. So whenever you say, I'm going to hit mock bin or something, it'll proxy that up to HTTP bin. That's all it's doing, right? That's all we're attempting to do. And I'll be honest, like I have some admission here. I have a confession to make. So
well, it's getting deep, is this?
I understand Kubernetes services and primitives so well because of things I did at vSphere and like even in networking. But I didn't really understand like API gateways as much or how they've transacted until like I literally just started deploying one and messing around with services and routes and realizing, wait, like I can map all of this to Kubernetes very easily. And when you actually peel away those layers, you begin to realize they are effectively the same thing. It's just called something different. And that's what I love about this like tech world, right? We'll call like the same thing 15 different names to achieve the same goal. Anyways,
I know.
Let's keep going.
And we go round and round in circles as well. It's like everything old is new again and things like that. You know, like the BGP journey that we're all on again. Yeah, here we go. So I've got the Kong docs open here for setting all this up. So I'm going to basically step through all those just to show you what it kind of looks like. So managers all up. We have no services. So I showed you that earlier. If we curled that admin/services, there's nothing for us to look at. So we'll create our first service. So we're going to give it a name, items. And then this is going to be the endpoint. So as we mentioned, we're just going to hit an upstream URL, which is going to be this http:/anything. And then, yeah, we're just going to save our config. So this becomes our first gateway service. So what we then need to do is add a route.
So while you say that, if I were to go into Kubernetes and create a service primitive, same thing, exact same concept, right? It's an abstraction, but how do we get to it? How do we actually get to that abstraction? So next up is building that pathway.
Yeah. So we will create a route to our service. So we'll call this the item route. We will find our service that we created on the previous page. I think we'll leave that as default. And then we can select a number of different things here that we want. We could specify which methods we allow. We could potentially, I guess, do host lookup to specify which hosts are allowed to go in there, and a variety of other fields as well. So let's specify our path as /items. Right, and let's save that. So we now have a path defined and a backend service for that path. So that's effectively the bare bones basic setup for everything that we're kind of talking about. So in theory, if our port forwarding has worked, ta-da! So that has worked. So we can see here.
So if you look at that line where it says xkong request ID, we know that Kong right there, exactly. So Kong is the mediator or the proxy that's handling the request. That's how we identify the proxy is working. And right above that, the xforward prefix, and then above that, the xforward path, that's where we're destined to go to. Yeah. But if you notice the host itself, just a little bit up top, just a few lines up top, it's httpbin.org. So it's like, in a lot of ways, I just created a C name in DNS for another resource. Pretty much, right? That's what we're doing with proxying here. Except with DNS, you can't really modify your request. You're just basically creating another name for the way to get to that original name. Here with this proxy, if the request comes in, we can evaluate it against policies, against whether or not it has authentication. So if I were to throw in a TLS key there, and create a consumer that consumes that key. And if I just went to try and attempt to access the service, it would fail because I didn't specify the key in my header, right? So there's a lot of things you can do to manipulate the traffic flow, and it's very synonymous with how we do network routing. So that's it. Like, we're done.
Well, I mean, I think there's definitely, this is effectively the simplest way of showing you the concept of creating we've just created one backend service here, but we can have zillions of them. We can have routes that go all over the place. I think the magic really kind of comes in when we look at the plugins.
Exactly.
And this is
click on the plugins.
Clicking on the plugins. We need a new plugin, so let's click on new plugins. So here we are, and like, this is where we're really injecting magic into the path, as it were. So I mean, at the moment, we've created a crazy path where a request is taken and forwarded elsewhere, and things are injected. Here we can really inject a lot more kind of clever logic into what's actually occurring. Basic authentication. As we mentioned, if I inherited somebody else's APIs, I might not be able to change them. And if authentication is a requirement for security or whatever, this is the way that I can then modify that existing application so that that API suddenly has authentication built in. As far as anybody's concerned, it's built into the API itself.
Exactly. So you could modularize this and pick the kinds of plugins that you need. Something else to consider, though, is that in complex environments, you're not going to just be using a single plugin. You'll be using multiple plugins. And there's even an order of operations which you can use these plugins in, right? Like, you'd want to authenticate first before you allow anything else to happen. Because once you authenticate, you can determine how you want to rate limit that consumer, right? So you can also modify the order of operations in which these plugins operate in. There's some advanced stuff too that's like up in the enterprise space. In fact, there are even third-party plugins that exist as well. So you have a variety of options to kind of mess around with. Anyways, we can go on for hours about the different kinds of plugins, but it does resemble a lot of functionality of what you would see inside of a service mesh. So maybe let's spend the last few minutes talking between the differences between what this gateway is doing, what an ingress controller is doing, and what a service mesh is doing. So we've seen the API gateway, and it's not centric to Kubernetes. It can pretty much live anywhere. Excuse me, one second, I'll be right back.
No problem. I am conscious that we have 10 minutes or so, but if people do have questions, please do throw them into the comments. We will try and answer them as and when they come in. Sorry.
So the gateway API, the API gateway itself can live in an EC2 instance. It can live in a Linux VM. It could live in a Docker container. It can live anywhere, right? That's the irrelevant part of it. What's important, though, is depending on the workload environment that you're using, maybe you might get influenced to use something like the Kong ingress controller, which is a lot more Kubernetes native because you're not configuring your services and routes in Kong Manager now. You're configuring them with Kubernetes YAML. Like, Kubernetes will process these resources for you and configure the respective infrastructure. Now there's also Kong Mesh, right? Or even service mesh technologies. So you've got an API gateway. Why can't I just use a service mesh to take care of all of this? A service mesh can do a lot, but it can't do all of what an API gateway does, because an API gateway is doing some additional processing. It's a little bit more dedicated. It's a little bit more dedicated towards north-south services, servicing external consumers and clients. Whereas a service mesh, you're going to pick and choose pieces for your service-to-service connectivity, and you're going to evaluate whether or not you're going to even rate limit service-to-service interactions or authenticate or leverage something like mutual authentication or TLS between your services. And a lot of this originated from the fact that, hey, what if a container made its way into the environment that was a malicious container and started talking to other containers and then causing DDoS internally, which is one part of it. And then the identity piece comes in and is addressed by service mesh because you've got a certificate that tells and attests who this workload is and where it came from and where it's supposed to be. So that's where it really shines, and it can shine in different ways too, especially as you're scaling internal services. But this begs the question: do I need all three? Do I need one or the other? That's another. It depends.
Amazing. No, I mean, I've always been like, please. We talk about this all the time, but you go to the CNCF landscape and your head explodes. You don't need everything. You really need what makes sense for what it is that you're aiming to achieve. Like, I know it's very tempting with all the new and shiny various things out there, but you don't need everything to achieve. You only need the bits that will help you achieve your goal, basically. So yeah,
that is exactly it. If you need a mesh, you're probably evaluating a whole bunch of other things as well, and you've got stronger, stricter compliance requirements that you need to meet or adhere to. But other than that, there's plenty of architectural design guides out there on the internet that really explain how you would go about picking one or the other, or how you would use both together, because there are environments that do just that.
Mm-hmm. Very cool. Yeah, I think we're kind of getting close to the end here. I don't think there's going to be any more questions for today. So I think before we kind of wrap things up, as I say, all of this, which is all wrapped in make files and all the config that we kind of talked about today, is going to be added to the isovalent eCHO GitHub repository. So as long as you have Ubuntu, make the kind binary and largely it, I think, at this point, that will effectively take care of spinning up absolutely everything for you and give you an environment end to end that has all the load balancing capabilities and a API gateway on top. It also has a gateway API example in there as well, just to confuse you a little bit, because that's where I was originally hopefully going to go today, but I just felt that it was just going to confuse things far too much if we tried to just do too many things at once. So that will all be in there.
Before you do end though, why don't we take a look at that gateway API config quickly?
Yeah, sure. So let me say goodbye to all of these plugins. I certainly do want to play with the basic authentication at some point. Yeah. So I'll quickly bring in terminal, my terminal again. I think this is the right one. Yes. So, and then I'll actually bring it in. Right. So we're in the directory. So one thing we need to do is, so what we're doing here is we're effectively adding in a bunch of CRDs that make our Kubernetes cluster gateway API aware. So if we look at things, what's the important more? Here we are. So HTTP routes. We don't really have time to fully go into this, but there are a number of amazing videos on eCHO and also upstream by SIG Networking that detail all of this. But effectively, you have a gateway and you apply routes to it, like we kind of showed earlier, with the services that we had inside our API gateway. So our HTTP route effectively will be a route that's applied to a gateway. That gateway typically will point to a load balancer address. And then our backend typically will be a service within our Kubernetes cluster. So our cluster is now aware of things. If we do, so there's no routes defined at the moment, but our cluster is now aware of the concept of a HTTP route. And then I think in here, yes. So things may break because I already are using. I'm already using some of these addresses. So let's just. I've done this the other way around. You see, normally when I went through this demo, I did Gateway API first, where I would get that address before anything else would. But bear with me. So here we have our gateway that we're going to define. The gateway is of type Cilium. The address that it's going to use is this particular address. and it's going to listen on HTTP. And I think, and it's going to allow routes from any namespace. So this is probably not going to work because I've done this completely backwards. All right, let's. Oh, come on, slowly, slowly. Right, okay. So effectively, the problem that we have here is that I don't have enough load balancer addresses for my gateway.
I was going to make a comment about the /29 you used there earlier.
Yeah. We'll save the Gateway API demo for another time. But effectively, yeah, we've done a number of demos about this before. If you do want to recreate this demo the right way around, I'll add this in the README, but basically, this is a very small cluster with not a huge amount of IP addresses in the original config. So we basically ran out of addresses to use for the gateway that we were going to create here. Fridays. Never demo on a Friday. Happens. But effectively,
it's a /28, man.
Yeah, I should have done. lessons learned for next time. But as I say, it's all in the repo anyway. If you want to play with it, please do. If you have any additional feedback, questions, queries, suggestions, find us on the Cilium and eBPF Slack instance. There's also a Cilium channel on the Kubernetes Slack instance. If you're having any issues with any of the code or makefiles or any of the things that we use today, then please contact Marino directly. His phone number is, just kidding. Please just raise issues on the eCHO isovalent repository. As I say, everything will be in the episode 145, and everything will all be in there for you to play with. So the main demo went okay, so I'm not too upset. I'd like to say thank you very much to Marino for taking the time for joining us today and helping us understand what is a gateway. Well, the differences between Gateway API and API Gateway. I still think, unfortunately, due to the close naming, it's going to be a bit confusing for everybody for quite some time, but we'll get there, I think.
I agree. It is convoluted, but hey.
It is what it is.
I'll make a comparison table for y'all at some point, and then we'll make it easy.
Awesome.
But I do agree someone should rename Gateway API to something else.
I'll raise a PR immediately. I'm sure they'll be more than happy to rename everything at this point in the day. Awesome.
All right.
Well, thank you, Marino.
Dan, thank you for having me on, and thanks to the audience for coming by and hanging out with us. It was a great episode. Thank you.
Cool. Thank you, everyone, and we'll see you all next time.
Take care.